In this video, we are going to take care of input system initialization and configuration.
Okay.
What we're going to do is we're actually going to turn our attention to the config class. And inside of config, we're going to set up a temporary example map set. Then we'll initialize our input system using this map set.
Okay.
And the idea is that in our final finished game, input map sets are going to be created through key binding. We'll actually look into the XML file, we'll read lines out of that which will indicate what device inputs get bound to what internal game inputs and any additional information that goes along with it.
Which means that potentially a user could go into that XML file and take, say, the A button and map it to something else.
Exactly. At that point, the button configuration can be handled externally from that config file.
Cool.
Now that is a topic unto itself, the act of going through the XML file, reading out specific nodes, and binding those to the map sets. So what we're going to do in this lesson is just get the initialization for our input system set up, and then we'll create an example map set. We'll make a simple function that will map just a handful of keys so we can see what is necessary to put a map set together.
All right. Basically getting the functionality in place without dealing with the XNA stuff yet.
Exactly.
Or, I'm sorry, the XML stuff yet.
XML, rather.
You know what I meant.
But let's go ahead and jump in to our config class, which we still have open over here in the environment. And we're going to need to add a few things. We'll need to add a field and a few methods. Since some of these methods are going to deal with input functionality, we are also going to go ahead and add a using statement. We'll drop in a using statement for input. So Microsoft.xna.framework.input. That should give us access to all the types we might need. And let's see, where do we want to jump in? We'll go right here below load options, and we'll make a few methods. We'll make a method called load input. So we'll have public static void load input. And we'll have another method called load simple map set. So public static void load simple map set. And we will take in a map set parameter here. And we'll call that map set. And we also need one more thing. We're going to need to hold a field here inside of the config class for the actual map set itself. Because, of course, the idea with these map sets is once we get into more complex scenarios where we have game input, or rather menu input for input screens, and then those input bindings will be different than things like our actual gameplay input.
Gotcha. So, like if you're playing with a drum set, hitting a drum will cycle down through the menus while you're in a menu, but then it'll play notes when you're actually in the game.
Exactly, and that means we're going to have entirely different input sets for a menu versus for a game.
Okay.
So what we'll do is we'll hold those input sets as map sets here in config, and that makes them easily accessible and easy to swap out.
Cool.
So we'll jump in here to our fields inside of config, and we'll add a field called, let's see, public static map set, and we'll call this game maps. And the idea here is that game maps is going to be our input mapping set for when we are in gameplay mode. At the moment we don't have a menu system, so we won't worry about any type of menu binding map set. Now we can turn our attention to our load input method. Inside of load input, we're going to need to set up the map set, initialize our input, and then make sure that our input is looking at the current map set. So what we'll do is we'll take our new game maps field, and we'll say that that is equal to a new map set. And then once we have that map set established, we can turn around and initialize our input. So we'll take and look at our input class and tell it to initialize. So of course internally that means it's going to go in and make sure any devices that have events will be linked into the internal handlers. Now we need to populate this game map set, because if we looked into what this is, game maps is a map set. Back here inside of input, all we've got is a dictionary, and then nothing happens beyond that.
Right.
Once we create a map set, we have this key map dictionary that's going to reside inside of it, but it's going to be empty. So what we need to do is go through and fill this dictionary. So over here in load input, we'll do that with a call to load simple map set. And load simple map set is going to ask and say, well, what map set would we like to load input into? And we'll pass in game maps. Then once we have that map set established and ready to go, we'll pass it on to the input system. So now we make sure that we tell our input system to change map set and pass in game maps.
So you're basically laying down the structure that allows you to change these maps out on the fly.
Exactly. Now the only thing left to code in is exactly what happens in load simple map set. All we're going to do in here is we're going to add entries into our key map dictionary, and we're also going to make sure that we tell the keyboard input class to look out for the keys that we would like to be bound.
Okay.
So we're going to begin with mapset.keymap. So we'll look inside that dictionary, we'll address keymap, and we will set the element, and this is where we can start to look at this dictionary more like a more classic container type like list. We'll just address these by index here. And we'll say that map set element keys.up, and we will bind that to a new input data struct. So I'll say new input data, and this is saying that, okay, the up key is bound to named inputs.up. We'll bind this for player 0, and the data being passed in is irrelevant here, so we'll just pass in 0.
Okay. Because that would technically be your track number, right?
Yep, exactly. So we're saying that this is the up button. It's never going to look at a track, so just pretend it was track 0.
Sure.
Because in this case, we're never even going to use track. Now, you will note a couple of things. One, if you're just getting, or if you're new to working with dictionaries, you may wonder why we can assign it directly. Because at this point in time, the key map, or excuse me, the key up does not exist inside of the key map dictionary. Fortunately, though, we can assign in this manner. Basically, what this statement would do is it would either set or overwrite the up key.
Okay.
And this is useful because if we already had a key in up, we would simply overwrite it. And if we don't have it, then it will get created in the first place.
Okay.
You'll also notice that IntelliSense is not happy with directly passing in this enumeration element.
Which we saw earlier.
And again, the dictionary is looking for an integer, not an enumeration. So we'll cast that to int before we pass it in. Now, we've set up the association where a keyboard key ends up getting linked to a named input button.
So that would actually be the up arrow on the keyboard, right?
That's right. Keys.up would be the up arrow.
All right.
So we've got this association set up. So now we can translate keyboard input to internal input. But we need to remember to tell the actual keyboard input device that it now needs to be looking for the up key. Because we're never going to get up here into the input class if keyboard input never says anything.
Right.
So we also need to tell keyboard input
to start looking for the up key.
Exactly, and we'll do that using the add key method. So tell keyboard input to look for keys.up. And now keyboard input will tell the input system that the up key got pressed. The input system will look at the key map dictionary and say that, we do have an entry for the up arrow key. And that up arrow key is associated with our named input up.
Gotcha.
And then that's the event that will get fired back to our game that says, hey, the internal event named inputs got fired. Now we're going to do the exact same thing for the down key and for the Z key. So I'll grab these 2 lines of code and I'll paste them a few times to duplicate them, and maybe space them out a little bit. And we will bind the down arrow key to the named input down. So keys.down will be bound to named inputs.down, and we'll tell our keyboard input to look out for the down key.
Okay.
And finally we'll set, or rather we'll bind the Z key to the named input key, named inputs.note. And then make sure that our input system is looking out for the Z key. And that takes care of a very simple binding. So internally, as far as our data structures are concerned, this is key binding.
Right. Later on, this will be something we wipe out and replace with some code to handle pulling this in via an XML file.
Exactly, and that'll have a lot of its own topics to discuss, meaning how we walk through, or even in the first place, how we store key bindings in an XML file.
Right, but that's for later on down the road.
But now that we've got our load simple map set put together, now we're ready to turn around and set up the input code inside of our game class.
Okay.
Before we leave here, let's build briefly, make sure we have no syntax errors, and then switch over to our game class. Inside of game, the first thing we'll address is the constructor. So up here at the top, right after we do a config.load options, let's turn around and do a config.load input. So the implied action here is that we get our input configuration loaded up and things like the XML file read in, though in actuality the input system itself gets initialized.
Right.
One nice thing about that is that keeps our code in the game class very clean. We don't have to worry about, well, does input initialization happen before configuration, after configuration, in load content, or some other place. We just know that in addition to loading input, the config system will make sure that the input system is in turn ready to go.
Okay, gotcha.
Now let's move down to the initialize method. Inside of initialize, here in the game, we need to look out for whenever the input system tells us that input was pressed or released.
And this will be code very similar to stuff we've already seen.
Exactly. So, I mean, the look and feel of this is exactly like when we were dealing with the keyboard. The nice thing here is that it is generic and it is in internal format. So, we will look at the input class now. We'll say input.input released, and then plus equals tab to accept the new instance of our delegate, and then tab again to accept the name of our handler method as input_input released. Now we'll turn around and back to initialize, above the input released line, we'll drop in input.input pressed, and plus equals accept the delegate, accept the method handler, and now we have two methods, input released, or input pressed, and input released, and everything is all linked up nicely. Now inside of each of these handlers, for the time being, all we're going to do is show at the log that something had happened. Right now we don't have anywhere for this input to go. We don't have gameplay in place, we don't have a screen system in place, we don't have a menu system.
Okay.
So all we're going to do is put together some simple lines to show that our input system is working.
Just like the test we were doing earlier.
Yes, this will be exactly like the keyboard test. So we'll say input.WriteLine, and we'll say that an input was pressed.
I mean log.WriteLine.
Or excuse me, log.WriteLine. This is, yeah, you will admit this is a lot of names that all going together.
It is a lot of naming, that's right. No worries.
So we've got input pressed, and let's feed in some piece of information in argument 0. I'll say that argument 0 is actually going to be the input data dot named input.
Gotcha. Which will be whatever bound key we have. So it should turn back, what, up, down, and note?
Yep. And we'll do the same thing inside of input released. And we'll say that we have input released, and then argument 0 will be, again, named input.
So it's nice and generic so that even at this point we could create code for other types of input devices and it would still work just fine if everything was bound up.
That's right. At this point, we don't care if that input originally came from a keyboard or a gamepad controller or a brand new device that we don't even know exists yet. Whatever it came in as, we don't care about anymore because now it's in terms of input data and named inputs. Alright, one last thing we can do before we test all of this out is we need to go into update, and we need to make sure that we pass along update calls to our input class. And this is simply a case of saying input.update.
Which is in turn calling, what, keyboard.update?
Yep.
Or keyboard input.update?
Exactly. And then in the future we'll also call gamepad input.update.
Sure.
And so
whatever
on.
it needs to.
We're also going to remove the default code that causes your game to exit when the back button is pressed.
Yeah.
Since that will become problematic when we start adding gamepad input, and all of a sudden we want to go back from the song selection screen to the main menu screen, and instead we just exit the game. So we're going to pull that out entirely. So all we have here at the moment are input.update and our base call to update.
Nice.
Now, if all goes well, we should be able to, at this point, run the game and see our simple input with the up key, down key, and Z key.
Well, I'm ready to go. Cross my fingers. Looks
Here
good
we go.
so far.
Inside the game is now running. If we hit the up key, we see we get the input was pressed and then released for up. And the same for down.
Nice.
And the Z key results in a note being pressed.
Very cool. So we actually do have simple key bindings taking place right now.
Yep. And you'll note that we still have the press and release behavior, meaning if we press and hold the up key, we see that we got the input pressed, and we're waiting until we release the key to get our release event.
Very nice.
Everything is still working in the event-based system.
Very cool. So is there anything else you want to accomplish in this video? I mean, we've got our... I guess we technically have the input system taken care of, don't we?
Yep, this is it. The core input system is now in place.
Mm-hmm.
Any future lesson dealing with input will involve enhancing the input system.
Gotcha. By implementing other devices, I suppose?
Exactly. We'll be doing things like, inside of input, we'll be doing things like adding additional dictionaries to MapSet.
Gotcha.
We'll be adding additional event listeners to the various input devices. And we'll be adding additional handler methods.
Mm-hmm.
Of course, we'll also have to address some things in configuration to get all of those bound up. But this is it. This is the heart of our input system.
Very nice. Well, that sounds great, and that is going to wrap things up for this video. Thanks.